so chapter 5 gets into all things polynomials. Okay, so 5.1, we're going to look at degrees of polynomials. We're going to look at end behaviors of polynomials, and then we're going to graph them using the calculator, finding the zeros, and using a table. And then we're going to do the range and end behavior from a graph. Okay, so a monomial is just one term, like an x or a 2, or even a 2x, okay? Just one specific thing, nothing added or subtracted behind it. A polynomial is anything where you have more than just one term. So you can have a binomial, which is 2 terms, or you can have a trinomial, which is 3, or obviously more than that, and we just say it's a polynomial from there, okay? For it to be a polynomial, not everything is a polynomial. So for it to be a polynomial, you have to have whole numbers for exponents. Your variable cannot be the exponent, okay? Your coefficients are real, and your variable also cannot be in the denominator. So if you see your x or whichever variable in the denominator of a fraction or as the exponent, it's not a polynomial, okay? Everything else would be. For it to be in standard form, you have your highest exponent, and it decreases down to your constant, okay? So you'll have to check for some things throughout this chapter to make sure it is in standard form, okay? The degrees of polynomials. If you are looking and you only have one variable, okay, the degree of the polynomial is your greatest exponent, okay? So if it was in standard form, your greatest exponent comes first. It's your first term. It can break down into what type of polynomial you have depending on the degree you have. So a first degree is just x, so that's linear. A second degree is x squared, so it's quadratic. Third is x cubed, so that's cubic. And then x to the fourth would be quartic. X to the fifth is quintic. Okay. You will eventually need to identify what type of polynomial it is, so it would be good to know what those things are. Usually you only have to really focus on the fourth and fifth because 1 through 3 is easy. Okay. Now, I said that if you only have one variable, then your highest exponent is your degree. But if you have more than one variable, like these two examples, I have an x and a y and an x, y, z, your degree is actually the sum of all the exponents per term, okay? So you would add all your exponents and then see which one has the greatest sum. That would be your degree, okay? So if all I'm looking at is 4x squared plus x minus 7, I only have one variable, which is x. So my degree, it would be the highest exponent, which is 2, so it would be a second degree polynomial. Okay, if I'm looking at 3x squared plus x squared y squared minus y cubed, this first term has a degree of 2, but then this second term, x squared y squared, there's 2 variables, so I add the exponents, that gives me a degree of 4, and then I have y cubed, which is a degree of 3. So if I'm looking and comparing those, what is my actual degree of that polynomial? A 4th degree polynomial. So then, if I look at my next one, negative 2x to the 4th y cubed z plus 5x y squared z minus 6x squared y squared z cubed, I'm going to add all of those together per term. So x to the 4th y cubed z is going to give me what? Give me 8, right? Because that z has an exponent understood to be 1. And then x y squared z would give me 4, and then x squared y squared z cubed would be 7. So what degree do I have for this polynomial? An 8th degree polynomial. Okay? We're good with that? Alright. Now, when I tell you to evaluate f of x equals 2x to the 4th minus 5x cubed minus 4x plus 8 when x equals 3, you're going to start that like you would any other thing. You're going to take this x equals 3 and you're going to use direct substitution everywhere there's an x, you're going to replace it with 3. So f of 3 equals 2 times 3 to the 4th minus 5 times 3 to the 3rd minus 4 times 3 plus 8. Okay, now do I understand you could type that in your calculator? Yes, but we're not going to. Okay, we're going to do order of operations and we're going to work it through. So what I mean by that is we're going to evaluate what is 3 to the 4th power. 81. So 2 times 81 minus 5 times, what's 3 cubed? 27 minus 4 times 3 is 12 plus 8. Okay. Then we're going to multiply. 2 times 81 would be minus 5 times 27 minus 12 plus 8. Okay. Then you can add all of that together, combine everything, and that leaves you with should be 23. So I expect to see you work through that, okay? Super simple though, so shouldn't be anything where you would lose points, okay? Now, the main part of these notes are looking at end behaviors of a polynomial, okay? So we've got a few different functions. We're going to go from quadratic all the way to, I think, quintic. And we're going to look at what happens for our end behaviors. So what your end behavior is telling you is where your graph is approaching. So as x approaches positive and negative infinity, where is my function approaching? Okay? So you have to get your left and right and your up and down separate from each other. Okay? With end behavior, it's determined by the degree and the sign of the leading coefficient. Okay, so as long as it's in standard form, you're looking at your first term and your first term only. You're looking at that exponent, and if it's odd or even, and then you're looking at the sign of your leading coefficient, positive or negative. Okay, so if I'm looking at just y equals ax squared, okay, we're going to identify two things, which is the degree and the leading coefficient. Okay, so if it's x squared, my degree is 2, that's an even degree. So we're not going to just tell the number, we're going to identify what happens if it's even, what happens if it's odd. Okay, now my leading coefficient is positive. Okay, so your leading coefficient actually tells you where your graph ends. Okay, so it's an end behavior, all right? With your end behaviors, you're going to write two statements, and you're going to write it over and over and over throughout these notes in your worksheet, okay? So if you write it in this order, then there's only one thing changing, and it's the same every single time, okay? So it's f of x approaches, this little arrow means approaches. F of x approaches blank as x approaches negative infinity, and then f of x approaches blank as x approaches positive infinity. Okay, so we're going to have that written down every single time, and the only thing that changes is where I put a blank. Okay, so break it down, what does this even mean? So x approaching negative infinity, think about your x values. Okay, if I'm going to negative infinity, where am I going? For my x, it would be left. So I'm analyzing where is my function going on the left side of my graph, which is the start. Okay? And then where is my function going as x approaches positive infinity? That means on the right side of my graph, or where it ends. Okay, where does it start? Where does it end? Okay, now notice I'm doing f of x. So f of x is my function, which is the same as what? If this is x, f of x is y. So my only options are what two directions? up and down. Now, I'm not going to say up and down. We're going to use in terms of positive infinity and negative infinity. Okay, so if I'm looking as x approaches negative infinity, the left side of my graph is going where? Up. So that would be positive infinity. Okay? As x approaches positive infinity, my graph is going where? Up, so positive infinity again. Okay? So, what if I change it to make it negative? Okay, well, I'm going to go ahead and write my template, f of x approaches blank, as x approaches negative infinity, and f of x approaches blank as x approaches positive infinity. Okay, and I said only two things matter, your degree and your leading coefficient. Okay, well, the only thing I changed here is making my leading coefficient a negative. My degree is still even. Okay, so what I'm looking at, as x approaches negative infinity on the left side, where's my graph going? Down, so it would be negative infinity. What makes it go down? The negative leading coefficient. Okay, so as x approaches positive infinity, which is the right, my graph is going down still. Okay, so this was just quadratic. Okay, and we know a negative leading coefficient makes it go down anyways because that's our reflection. Okay, so if we bump it up to a cubic function, I now have ax to the third power. Okay, so I'm going to start my template, f of x approaches blank, as x approaches positive infinity, negative infinity. And then f of x approaches blank as x approaches positive infinity. I always do negative infinity for my x first because that's my left, and then my right side. Okay? Now here, what's my degree? It's 3, so it's odd. What's my leading coefficient? Positive. Okay? So if I'm looking as x approaches negative infinity on the left, where's my graph going? Down, so negative infinity. As my graph goes to the right to positive infinity, as x approaches positive infinity, where's my graph going? Up to positive infinity. Okay, so if you heard me a second ago, I said your leading coefficient tells you where your graph ends. So that's going to be on the right side. So my leading coefficient is positive, so it ends positive. Okay. Now here, y equals negative ax cubed. All I changed was a negative. And we're going to analyze what happens with that end behavior. So as x approaches negative infinity, which is my left, where's my graph going? It's going to positive infinity. The right side goes where? Negative infinity. Notice that my leading coefficient was negative, so it ended negative. Okay? So then for quartic, what do you notice? My degree is back to what? Even. So here my leading coefficient is positive again. So we're going to set up our end behavior template. On the left side of my graph, on the left side, as x approaches negative infinity, where's my graph going? Positive infinity. What about the right side? Positive infinity again. Okay. Now when I make it negative, where's it going to go? My degree is still even. My leading coefficient is now negative. So as x approaches negative infinity, where's my function going? As x approaches positive infinity, where's my function going? Negative infinity. Because my leading coefficient is negative. Okay? Now, when you flip it over, I want you folding your notes because I don't want you seeing that bottom half yet. Okay? So fold it like that. Okay? We're only looking at the quintic function. Okay, my degree for quintic is to the 5th power, so that is odd. My leading coefficient, positive. Okay? So if I set up my template, as x approaches negative infinity for a positive leading coefficient, where's it going? Negative infinity. As x approaches positive infinity, where's it going? Positive infinity, because remember, your leading coefficient tells you where it ends. Okay? So then, if I make it negative, where's it going to end? Negative. If my leading coefficient is negative, then my graph's going to end negative. So, for my end behavior, as x approaches negative infinity, where is it? Going to positive infinity. And as x approaches positive infinity, my function approaches negative infinity. Okay? So, without looking at the table that I give you, look back through, what do you recognize between a quadratic and a quartic? What are the similarities? Quadratic and a quartic. So x squared and x to the 4th. So you should just be able to lay your 2 pages out and look at x squared and x to the 4th. What are the similarities there? What's the same? Okay, so besides the graph, the answers look the same. Okay, so that means what else is similar between x squared and x to the 4th? What do you think is making those two the same? The degree. The degree being even makes it go where? The same direction. They're either both going to end up positive or they're both going to end up negative. Okay? And what indicates if they're going to end up positive or negative? The leading coefficient. Okay? Now, your cubic function, what's different with your cubic function versus your quadratic or quartic? They're opposite directions. Okay? What do you think is making them opposite directions? The odd degree. Okay? So when your degree is odd, your graph goes in opposite directions. When it's even, it's the same both sides. The sides are even, they're going together. Okay? When it's odd, it's opposite. Okay? You have to know your leading coefficient tells you where it ends. So if you know where it ends, you're starting in the opposite direction, odd opposite, okay? So same thing with quintic. They're going in opposite directions because it's odd. Odd opposite, okay? I started with the positive leading coefficient, so I ended in the positive direction. That means I had to start in the opposite direction. Y'all catch that pattern? Okay, that's what this is summing up, okay? So we did all of that to explore that pattern, okay? You have to know why. I don't like to just tell you this and have you memorize it. I want you to know why, okay? So if you need to write down odd opposite, that usually helps, because what's going to happen is I'm not going to give you a graph because you can easily tell that. What I'm going to give you is a function with no graph and no graphing calculator. And you have to tell me what the end behavior would be. Okay? So what are you looking at? Your degree and your leading coefficient. Okay? So if I gave you, say, f of x equals negative 7x to the 5th plus 4x squared minus 10. Okay? Say I give you this example. What's the end behavior? Well, you start with your template. I will not give you this template, so you have to write it. But even without this, you could talk through it, right? What would you know? It's an odd degree, so it's going to end negative because of the leading negative coefficient. That's all there is to it. Okay? So if you know your rules, which sum down to just two rules, your odd versus even, what if I gave you f of x equals 50x to the 6th minus 1? Yeah, my degree is even, so my graph is even. They end up in the same. They're going to end positive. So on the left and the right, they're both going to be positive infinity for my function. Okay? Y'all good with that? Okay. When y'all get back from lunch, we will do your graphs. Are graphing polynomials. Okay, you're going to find the zeros from your calculator, and your zeros are just your x-intercepts. Okay, and then we're going to use a table from the calculator, and then use those points, graph it. We're going to do our domain and range, and we're also going to do our end behavior. Okay, so with your calculator, this is going to be the only section that you need the calculator for. So when you get to your worksheet, do this section first. Okay, so go to your graph. Let's see if I can work with this glare. There we go. And type in your negative x cubed plus x squared plus 3x minus 3. Okay, and once you have that graphed, does everyone have that there? Okay. I'll give y'all a few minutes. You're going to type in this function. Okay, so once you get it graphed, to find your zeros, you're going to hit Menu, which is under the document menu, and then 6 and 0 is your first option, so you can just press enter. Okay, so Menu, 6, enter, will give you a dashed line, a black dashed line. Okay, does everyone have that on your screen? Okay, so what you're going to do is you're going to use the little, I guess what they call the mouse pad, to scroll it left and right. So what you're going to look for is you're going to go to the first x-intercept that you have, and you're going to go to the left of it. Okay, once you're on the left of it, it doesn't matter like how close or anything, as long as you're to the left of it. Okay, and then you're going to just click the middle button. And what happens is your screen will change from lower bound to upper bound. Okay, so once you clicked that middle button, if you were to drag it over to the right, you should now see a gray area. And then once you pass that x-intercept, the word 0 will pop up with a point. Okay, y'all follow me? Okay, then you just press that middle button again, and it just makes sure that you've got that point. So that 1.73, we're going to round to the 10th place. So it will just be 1.70 for that x-intercept. Okay, now that 1.73, that point is negative. It's in the way for whenever I do my second one. So what I'm going to do is I'm going to hover over it. See how on your screen, if you hover, you've got an open hand. Okay, and if you look at your mouse pad part, the center of that, it closes. So all you have to do is hold the center down until it closes. Okay, it has grabbed it, and now you can just move it over to the side, hit that center button again, and it will release it. Okay, I show you how to do that because it will get very crowded if you don't move that away. Okay, so I'll show you how to do it again because we've got 2 other x-intercepts to do. Okay, so Menu, 6, enter. You get the dashed line. You scroll that dashed line to the left of your x-intercept, which this I can tell is 10, but we're going to do it anyways. Hit that center button and then drag it, and you should see a point pop up with 0. Press that center button again. 10 is my second x-intercept. Okay, so then I go and I hover over it and I hold the center part, and then I can move it over to the side, hit the center button again to release it. Okay, so then Menu, 6, enter. Do it again. Now I have a 1.73, and I'm just going to round that to 1.70. Okay? Does everyone understand how to get their zeros from the calculator? Okay. So now we're going to build a table. So to get your table, you do Control. Just hit, you don't have to hold it down like a computer. Just hit Control and then the letter T for table, and your table will pop up. Okay? And so there's no specific set points that I say for your x values to use. All I say is go as far as you can negative to where it'll fit on your graph, and as far as you can positive to where it'll fit on your graph. Okay, so negative 324 won't fit on your graph. But negative 2, 3, I can start with. Include your zeros in the table. So negative 1.7 is not going to pop up on your calculator. So you're going to have to know where to put those points in your table. Okay? And then I'll have negative 1, negative 4, 0, negative 3, and 1, 0. And then again, it won't show 1.7, so I put in my 1.70. 2, negative 1. Now 3, negative 12. Y'all can't see me writing. 3, negative 12. Yeah, it goes off your graph, but you can see where negative 12 goes. It's only 1 point off. So then you're going to plot those points and graph it. Now I want to make a point on your graph. Control T will get that table off. If you're looking at your calculator, so between 1 and 1.7, I didn't put a point in my table, okay? So you're going to have to look and notice that that in between those 2 points does not even reach a 1. So if you are going and you're graphing this and you make this go up high, I'm going to count points off for accuracy, because even though I'm not making you put a point there, you should be able to recognize this does not go higher than maybe 0.5. Do y'all see what I'm talking about? Okay, so that little local max point, when you're doing your graph, it should resemble what's on your calculator. So then once you graph it, we're going to do our domain and range and then our end behavior. Okay, now your instructions don't say domain, it just says state the range, but I don't remember if the worksheet says domain and range, so we're just going to do it. If all it says is range, just put range, but we're just going to go ahead and do it now. So remember, your domain is all the possible x values. So x, I scale it from left to right. Okay, so if I'm looking at the left side, I've got an arrow, so that means I do not have a boundary. Okay, even though it looks like I do, I don't. And on the right side, I have an arrow as well. So I don't have a left or right boundary. So as an interval, what would my domain be expressed as? Negative infinity to positive infinity. Okay, I can't remember if I asked for domain or not, because for all polynomials you have an arrow on both sides. So it should be negative infinity to positive infinity no matter what. Okay, now your range will depend on what your graph is. Okay, my range, I go from bottom to top. So do I have a bottom boundary? No. Do I have a top boundary? No. So then my range is also negative infinity to positive infinity. So then my end behavior, I set up my template. So as x approaches negative infinity, where's my graph going? Positive infinity. As x approaches positive infinity, where's my graph going? Negative infinity. And you can always double check. I had an odd degree, so they should be opposite. It's a leading coefficient with a negative, so it should end negative. So it all checks out. Okay? Questions on that? Okay. So then we're going to do the same thing. To get rid of this, just dock B, and it will clear it. So my function, x to the fourth minus x cubed minus 4x squared plus 4, is what I'm typing in. Once you graph it, you can find your x-intercepts. Menu 6, enter. I go to the left, press the middle button, scroll over to the right. Gives me 1, 0. I'm going to move the ordered pair. And then menu 6, enter again. Go to the left, go to the right. 2.380, what is that going to round to? 2.40. Then I'm going to build my table. So Control T. Negative 212 I'll include because that's just 1 point off the graph. Then negative 1204 10 2 negative 4. Then you'll have your 2.40. And 322 is not going to fit, so I'm not going to include that. So once you graph that, what's my domain? Negative infinity to positive infinity. Now this time with my range, bottom to top, do I have a bottom boundary? Yeah, I do. Where's it at? Negative 4. So what would my range be? Negative 4 to positive infinity. Okay? So you have to be careful with your range depending on what type of function you have, if it's going to be negative infinity to positive infinity or a set boundary. What type of functions are going to have specific boundaries? Odd or even? Even, because you're going either forever up or forever down on both sides. So with even degrees, you're going to have a specific range. Your odds, why are those going to be negative infinity to positive infinity no matter what? Because they go opposite directions. Okay, so that's going to lead me to my next question. Could you have an even degree polynomial with no x-intercepts? Could you have an even degree polynomial with no x-intercepts on your graph? Why? Yeah, this whole thing could be shifted upward. What if I tacked on, like, I did a transformation and I shifted it up? Or if it opened down and I shifted it down, it's possible. But my fundamental theorem of algebra tells me if I have an nth degree polynomial, I have n number of x-intercepts. So if you're telling me I can have an even degree polynomial with no x-intercepts on my graph, what happened to those x-intercepts? They're imaginary. So what you see on your graph is only the real x-intercepts, okay? So could I have an odd degree with no x-intercepts? Why? Because they always have to go opposite directions. Okay, very good on that. So putting connections together. Good job. Y'all's in behavior. Did y'all write that while I was asking those questions? So what happens to your function as x approaches negative infinity? And then your function approaches positive infinity again. Very good. Okay, do we have questions? Okay, so on your worksheet, I would do your graphs first. Number 17 is where y'all don't have to do the range this time on 17 because y'all don't know that point. I didn't teach you or the class before how to do max and mins yet. So on number 17 on your worksheet, you don't have to do the range. Okay?